Works now, yeah.
I think you need your smartboard buttons.
No.
Oh, that's boring.
All right. Write the electron configuration for calcium 2+. Or did we go through? Maybe we did go through.
We
it.
did
Yeah,
it
we
quickly.
We did it real quick.
We
Okay.
can just go to
So let's
P.
talk about this because we need to talk about where these electrons are lost from. Okay. So when we look at this, we are going to be looking at electron configuration that is AR and then 4s2, right? So these, we're going to be losing electrons. We know that we are losing electrons because this is a positive charge and electrons are negative. So this is where you're going to lose those electrons from. Then you can't write argon here anymore. You've got to write neon. And it would be 3s2, 3p6.
Yeah, so you put it AR.
No, because it's
Then that wouldn't be an electron configuration.
Nope.
because that's argon.
Okay, so the other question comes in, like if we were to take lead, okay, so let's take lead, all right? So lead is Pb, and it is, oh no, I don't want lead. Let's not do lead. No, I don't want, no.
Fluoride.
I
Francium.
want to, no, I want to do copper.
Oh, boring. We should do like zinc or something.
So copper is going to be Ar, right? 4s2, 3, or no, 3d. Yep, that's 3d.
3D9.
Is it 9? Yeah. Okay. So if we form copper, let's form copper 2+. Okay. So we're going to form copper 2+. It's got to lose 2 electrons. Now, your natural inclination is to take this number and do what to it? Subtract it down. But you're not going to do that. You take it away from here. The electrons are lost from the s and p orbitals.
Yeah. So take it.
So this ends up being your electron configuration. So you've got to be careful with those. Okay, it's going to lose it from the s first. Now you're going to get some of these, like that vanadium, it can have like a +6 charge. At that point, it probably will take some from the d orbital. But the first ones you take away to get to this are going to be from that s orbital. Good. Okay. That's a little confusing. We run into that every year. All right. Photoelectron spectroscopy. We touched on this last year if you were in honors. If you weren't, it's easy. Okay. All right. So this is where they're going to do and have an experimental data. They're going to end up with a graph that shows the relative number of electrons and their binding energy. Binding energy is the energy that holds those electrons to the atom. And they're pulling them away. Now, as you pull one electron away, what's going to happen to the binding energy of the other electrons? It's going to get stronger because you got more proton, ratio of protons pulling on those electrons increases. Okay, you pull another electron away, same thing. Okay, it's going to hold it even tighter. So the graph then is going to correspond to your electron configuration. Now, the first thing you need to do when you read these graphs is you need to look at the x-axis. Sometimes these graphs are written with the bigger number on the left side. Sometimes they're flipped around and it's written over here. So you've got to orientate yourself and find that big number.
You should have done it. You could have done a cool transition.
The big number
She's like, no.
indicates which side your nucleus is on. So this is your nucleus. That means that you're working out. Here you have 2 electrons. See, it comes up to the number 2 for the spike here. So this is going to be your 1s2. This then, notice that there's a difference in space here. As we increase distance, the hold on that electron is reduced.
Okay.
And back in the day, and we're going to talk about this more tomorrow when I give those notes, I personify this, okay? And I talk to you, I give you kind of an analogy of like a baby, okay? When that newborn baby, that mama is holding that baby really, really tight, okay? So the closer you are, the tighter that hold is, okay? Then you're a toddler. Now she's holding the hand. It's easier for that toddler to get away, but it's still close. That is your 2S level. Now you're going off to kindergarten. Does mom have as much control over you when you're miles away? No. Okay? So the further you get away, the less pull or less force there is on those electrons. This is your 1s2, or I'm sorry, your 2s2.
That's your 2.
This is 2p. Good Lord, I can't write today. 2p6. And then this is your 3s, and it's 1 electron. Now that I put my glasses on.
You can tell because the spike's smaller.
Yep, the spike is smaller. Okay? So you can determine what atom this is based on its electron configuration. This is
That's 3S.
sodium. 1s2, 2s2, 2p6, 3s1. You did this in honors, yes.
No, like this.
Oh yeah, we did that. I remember.
Yes, you did that in honors.
Oh my gosh, we did.
No, I think we did that.
All right. So sometimes you will see graphs that look like this because there is a gap here between the 10 and down to here. So they just ran out of room. Okay.
Oh, okay.
Essentially, this guy would come down to here. Where is my
Nucleus on the right.
nucleus? Is over here.
Yeah.
This is my bigger number. You always start at the biggest number.
Okay.
I don't know that it's necessarily going to be 100.
No, it's 1,000.
Okay? It could be different, but you find the bigger number. Wherever the bigger number is, that's your nucleus, and you work from there. So that's your nucleus. That means that this is your 1s2. We come down here now. This is our 2s2, and this is 2p4. There's only 4 electrons here. So this is what? Oxygen.
Okay. But good.
All right, down here, find our bigger number. Our bigger number, what is next to our bigger number? What do we write? Nucleus. Or we try to. Okay, there we go. All right, so this is my, figure out what this is. I'm not going to tell you.
Aluminium.
This is your 1s2. We go down here. This is your 2s2, 2p6, 3s2, 3p1.
Are we doing one? Is 1.7 periodic trends or the Coulombic attraction?
You're doing the Coulombic attraction today, and then we're lecturing on periodic trends, and you do that over the weekend.
Okay.
Yeah.
All right.
Yeah.
That's all the notes for today.